Hello. Hello.
Well, greetings to you too. So, this lesson, Unit 2, Lesson 3, is about systems of linear and nonlinear equations. Won't solve too many, but we'll set up some problems. A first-order system of equations is any that can be put into this form. That's our dx dt is some function of t, a function x, and the function y, and dy dt, change in y, is a function of t, x, and y. There could be more equations, there could be more functions. We could have a dz dt equals, I guess, j of t, x, y, and z, or something like that. So here's a typical example from chemistry. Here's what's going on. We have a chemical A that is breaking down into substance B. And substance B is breaking down into substance C. And substance C, see there's no arrow coming off that, so substance C is a stable substance.
Hot stuff coming up.
Yes, there is. So here is the system of equations that should show you the the best way to say this would be the model of this set of chemical reactions.
I can't wait.
Okay, so here's part of it. First of all, A is breaking down into B, so the change in A is proportional to the amount of A present, and since it's breaking down, then the change in A is a negative. This K would be positive, or you could just say K times A, and your K would be a negative number because it is breaking down.
I don't understand.
Well, the change in A is proportional to A. The amount of A that there is affects how much of A changes into chemical B. If you have more of chemical A, then more of A changes to chemical B. So the change in A is proportional to the amount of A that's present at a given time. And the change in B is interesting because two things are happening. One is it's the exact same as the change in A, only it's positive, because the amount of A that's changing to B is what's adding to B. So the change in B, that's adding to B. But remember, B is also breaking down, so that's proportional to the amount of B that's present. And so therefore, we'd say minus K2 times B. So now you see why we have a system of equations, and there really is one more equation. So you'd like to say, well, how is C changing? How's the amount of C changing? The amount of C changing is, well, sum of B is breaking down into C. So the C dt, change in C with respect to time, is proportional to the size of B, because that would be the amount of B that's breaking down into chemical C.
I know.
Oh, great.